Hey there, Mr. Sutton here with the AB Calculus Chapter 3 Derivative Extra Practice Number 2 Solutions. To take this derivative, it helps if you remember that 1 minus sine squared of x is really equivalent to cosine squared of x, because cosine squared plus sine squared equals 1. So if we make that little trig identity conversion there, we really have the square root of cosine squared, and then if you square root a square, you've really just got cosine of x. So we haven't actually taken a derivative yet, but now our task is much easier because the derivative of cosine of x is just negative sine of x. In order to take this derivative and make our lives a little bit easier, before I take the derivative, I'm going to start by using some log rules. So one rule I'm going to use that we don't use that often, but it's helpful here, is if I'm taking the log of a quotient, I can actually split that up into the difference of two logs. So I can rewrite this as ln of e to the x minus ln of 3x to the fifth plus sine of x. And one other little thing I can do here, ln of e to the x, well, the e's and the ln cancel. This is really just x. All right, let me go ahead and now take the derivative. Derivative of x is just 1, so that's nice. This next one is going to require the chain rule. The outer function, I've got ln of something, so the derivative of that is going to be 1 over the something, 1 over 3x to the fifth plus sine of x. But then I have to multiply by the derivative of the something. So derivative of 3x to the fifth is going to be 15x to the fourth. And then derivative of sine of x is going to be plus cosine of x. For this derivative, I'm going to need to use the quotient rule. So that's u prime v minus uv prime all over v squared. Let me set up the box and ribbon to help with this. So my numerator, I've got 3x squared plus 5. In the denominator, I have x squared plus 1. And then the derivatives of those, we've got 6x and 2x. Multiplying that out with the ribbon, we've got, 6x times x squared plus 1. That's the u prime v part of this. And then going the other way with the ribbon, we've got parentheses 3x squared plus 5 times 2x. And again, we're subtracting all that. And then finally, we're going to divide by the v squared, so x squared plus 1, that whole thing squared. To take this derivative, since there's no way to really simplify this, I'm just going to have to use the product rule, u prime v plus uv prime. And let me set up the box and ribbon for this. So my first factor, I've got an x. For the other factor, I've got tan cubed of x. Derivatives of those now. Derivative of x is just 1. And for tan cubed of x, I need the chain rule. My outer function is something cubed, so the derivative is going to be 3 times the something squared. So in this case, 3 times tan squared of x. But don't forget to multiply by the derivative of the something, which was tan of x. Derivative of tan is secant squared of x. And now, just using the ribbon to multiply all that out, we have 1 times tan cubed of x, so that would be tan cubed of x. Going the other way, we have x times 3 tan squared secant squared of x, and we're adding all that, and we're done. For this problem, I'm trying to take this derivative. I'm going to need the chain rule for this. My outer function is arcsecant of something. The derivative of that is going to be 1 over the something in absolute value times the square root of something squared minus 1. So that's 1 over absolute value of sine squared of x times square root of sine squared of x squared minus 1. Then I have to multiply by the derivative of the something. So the next function here, we have sine of something. Derivative of that is going to be cosine of something, so cosine of x squared. Then we have to multiply by the derivative of x squared. So that's going to be 2x. To take the derivative on this one, since I have variables in both the base and the exponent, I'm going to have to use logarithmic differentiation. So I'll start by taking the ln of both sides. I've got ln of y on the left side, and on the right side, this ln of x is going to pop out when I take the ln of the whole expression. So I have ln of x times the ln of the base, which happens to be x. So hold on a sec. If we have ln of x times ln of x, well, that's really just ln of x, the whole thing squared. Okay, so let's go ahead now and implicitly differentiate this whole thing. So on the left side, I've got 1 over y times dy over dx, because y is an inner function of x. And on the right side, we can just use a little chain rule here. So we've got something squared. Derivative of that is going to be 2 times the something, 2 times ln of x, but we also have to multiply by the derivative of the inner function. Derivative of ln of x is going to be 1 over x. And at this point, we just have to get dy over dx by itself, which we can do by multiplying both sides by y. So we have y times all that stuff. And they didn't say we had to get it just in terms of x, but if we wanted to, we could replace y with x to the ln of x and call it a day. To take this derivative, I'm going to use the chain rule. The outer function, I have something to the ln of 2 power. This is really just going to be a power rule since ln of 2 is a constant. So we're going to have ln of 2 times something to the ln of 2 minus 1 power. So that's ln of 2 times cosine of 2x to the ln of 2 minus 1. And now we have to multiply by the derivative of cosine of 2x. That's going to be, let's see here, we have cosine of something, so that's going to be negative sine of something of 2x that we're multiplying by, times the derivative of 2x, which is 2. So for this one, before we launch into taking the derivative and busting out the box and ribbon and a product rule and all the rest of it, we can simplify this a little bit. Cotan is really cosine over sine, so this is cosine to the 4th over sine to the 4th. And conveniently, these sine to the 4ths are going to cancel, so we're really just taking the derivative of cosine to the 4th of x. Now this is already a little bit tricky. We have a chain rule to use here. The outer function is the 4th power. We have something to the 4th. Derivative of that is going to be 4 times the something to the 3rd, so 4 times cosine cubed of x. But now we have to multiply by the derivative of the something, which was cosine. So we're multiplying then by negative sine of x, and this one's done. There are a lot of different ways of taking the derivative of this one. I chose to do a little bit of rewriting and simplifying first. So for one thing, with this ln expression, I can use log rules to pop out this 3 as a multiplier to go with the 32. So this is really going to be 96 ln of x, which is going to be a little bit easier to take the derivative of. Over here, I'm going to rewrite this thing. So part of the key is realizing that you can split up this radical 5x cubed into radical 5 times radical x cubed. So I can rewrite this as 6 over radical 5. And if I have 1 over the square root of x cubed, I really have x to the negative 3/2. And now I'm going to go ahead and take the derivative of all this. So going left to right, 90 ln of x, we can make that derivative 90 over x, 90 times 1 over x. And for this next one, this is basically just the power rule. So we've got negative 3/2 times 6 over radical 5. Well, the 2 and the 6 can cancel to give you a 3 up there. So this is really negative 9 over radical 5 times x to the negative 5/2. And that should do it. On this one, it looks like y is going to be kind of annoying to get by itself. So we're going to use implicit differentiation to make this a little easier. So going from left to right, whenever I take the derivative of something with a y, I'm going to have to multiply by a tail of dy over dx because y is being treated now as an inner function of x. All right, so on the left side, we're going to need to use the product rule for this first term. So here's my box and ribbon. I've got 2x squared as the first factor. Then we have y to the 4th as the other one. And now the derivatives of those, this is going to be 4x, and this is going to be 4y cubed times dy over dx. Again, we have to use the chain rule because y is an inner function now. All right, multiplying that out, that's going to be 4xy to the 4th, plus this will be, let's see, 8x squared y cubed dy over dx. And next up, we've got the derivative of negative 6x, that's negative 6. 2y, that's going to become 2 dy over dx. And now I'm going to get the dy over dx's alone and everything else on the other side. So this 8x squared y cubed dy over dx, that can stay on the left side. I'm going to subtract 2 dy over dx to get it over there with it. And then I'm going to subtract 4xy to the 4th to move it over to the right side. And the 6 that's already, I'm also going to move a 6 over there. So let me add the 6, and then I'll subtract that other one. Doesn't really matter what order we do that in. Now let me factor out a dy over dx on the left. That leaves me with 8x squared y cubed minus 2. And if I divide by that parentheses, I end up with my final answer. For this problem, it's looking like we're going to have a big nasty chain rule. But if you notice here, we've got cosecant of arccosecant. Those are inverses, so they actually cancel out. We can rewrite this as just sine of x cubed. And it's still going to be a chain rule, but a little bit nicer now. So outer function is sine of something. That derivative is cosine of something, cosine of x cubed. But now we multiply by the derivative of x cubed, which is 3x squared.